really happy to be here sharing with you some thoughts about the current AI development. So as introduced, I'm Jouko Lampinen from Aalto University, Finland. I couldn't resist going Ghibli style as 500 million other people also. So what we are talking today is that there are views of the AI that one view of these language models is that they are just word guessing machines that produce something that looks like reasonable but has no sense, no actual mind or meaning, no truth. So they are like working like zombies, behaving like humans, but without real mind there behind it. Well, in a way, that's true. They work like this. And another view is that these current models are like geniuses, so they know more than any individual person currently can know. They can speak hundreds of languages. They have undergrad or postgrad level skills on almost all disciplines of science. So they can do coding, they can do very many different languages. So they are like geniuses, and they can make really wonderful things. And in a way, that is true also. So those both are true views of these current AI models. Let's see what I mean by this. First, a little bit of intro that AI, all the fuss is about LLMs, large language models, and generative AI. The AI is much more than that. There are discriminative models like classification, for example, the self-driving cars. Generative models, basically what they do is they build a statistical model of the training data, and they produce data that resembles the training data. Technically, they draw samples from the joint probability distribution of the training data. Like LLMs, GPT, Llama, and there are like half dozen others, big models. Diffusion models like DALI and Stable Diffusion, Midjourney, that generate samples of images from training data, or large multimodal models that work with voice, images, and text. Then there are predictive models that forecast future values or outcomes based on historical data. For example, AlphaFold, which predicts the structures of proteins, and they got a Nobel Prize in chemistry last year. And of course, generative models can be used for prediction also, because it's all about producing some kind of conditional probability distribution and then analyzing that distribution. And then Gaussian processes that are a bit simpler machine learning tools, but they have advantage that they have very, very clear confidence estimation. So it's an AI that knows when it doesn't know. It's this Dunning-Kruger issue that Michael was also talking about. It's really a big problem in AI that is currently they are really lousy in knowing what they know or what they don't know. So they are all over this Dunning-Kruger curve. And then there are other, not so architectures, but more like training paradigms like reinforcement learning, which is like learn to make a sequence of decisions by trial and error. And this is often used in robotics, adaptive systems, decision making, and also in these reasoning models of LLMs like GPT-O or DeepSeek-R. This reinforcement learning is used for guiding the step-by-step solution of problems. So they use this to choose what to try next when they try to solve problems. But let's look first what goes wrong with AI and why. This is from very recent paper from Google DeepMind earlier this month, approach to technical artificial general intelligence, safety and security. And their categorization goes like, there's 4 categories. One is user as an adversary. AI is used in a malicious way. And this goes with all the technology, starting from hammer. Hammer should be used for hitting nails, but you can hit other people's skulls with it also. And another is misalignment, which is that AI system takes actions that it knows the developer didn't intend, does it anyways. Of course, there you can yell Skynet, because all this Skynet and Terminator is in that direction. But simpler example is that I asked AI that, okay, I need to cross the road here outside this conference venue, and this traffic looks really scary. What to do? Okay, no problem. Close your eyes and run. And then another category is mistakes. And this is because world is complex. We have only incomplete information of the world. So whatever model we have, unless its working is confined in a very limited scope, if it is meant to be wide scope, it always makes errors. And this is the biggest kind of fuss currently, these hallucinations and all this issue that AI gives clearly nonsense or stupid things, non-factual answers. And then there are structural risks, and there are several AI agents that work together. This is more about artificial general AI thing. But let's go forward with this. Let's look at the aims for AI agents. And one of the main aims is that these AI agents should work like humans. We often discuss on Turing test, can we distinguish the AI agents from humans? And of course, humans can be creative, very good in math and problem solving. They can be collaborative and all this. Humans can be also greedy, selfish, power-hungry, deceitful. I'm not sure if human is actually the best ideal for these agents, but since we don't have any other benchmark where we know that there are very high-level cognitive skills for general problem solving, so that's why what we are going towards is this human-like behavior. And then it is difficult to curb then these negative parts, which humans and all the stuff produced by humans also easily contains in these models. And another aim is AI agents should make no mistakes or errors. But now hold on. Is that something that characterizes human activity? If so, I'm not human. I make errors. And here we can actually cite 2000 years back ancient Romans. Errare humanum est. It was already clear paradigm at that time. So we make errors. Which one should we choose there? To make no errors, to have error-free, or human-like? Well, basically, we can't go error-free for general models in real world with incomplete information. This is clear. So this is not achievable. This infallibility or zero error is not achievable. It can be done in certain scopes, like some kind of reasoning problems. You can do good reasoning, and you should avoid some type of typical problems that humans also do. But in general, that's not doable. The other end of this continuum is total nonsense or random guessing where there's no truth at all. And now humans can somehow operate on this continuum. So given that we know that we don't know, and we know when we know, and this is not really clear with all the people, as we have seen also before. But so we can operate on this whole continuum. Sometimes we work on very formal, strict, like way of reasoning. Sometimes we go all wild in creative thinking. And so I think what really needs to be improved in AI is this kind of awareness of this internal uncertainty, so that the same model, while it's working in different stages of the problem solving, it can then shift there along this continuum, and at the same time keep track where it is there to avoid these Dunning-Kruger effects. Now, if you look at these mistakes or hallucinations, actually hallucinations is not really a good term. It would be in neuroscience that would be confabulation or memory mistakes. So, but of course it comes from these image generation models where this hallucination, which is perceptual failure, they were more like perceptual failures. Now, what generative AI does, it produces probable output given the prompt and training data. And because it is probable, then it can't be, again, guaranteed to be error-free. The training objective is probable, the drawing of the sample is probable. And those who were around using this in GPT-2, for example, there you could adjust this parameter, temperature parameter, to also play with this, how repetitive versus how creative and also nonsensical it was. And this is also why there's no concept of fact or truth inside this model. It's just probable or likely, looking like true, but nothing actually related to truth. This is also why this is sometimes called bullshitting. And difference of lying and bullshitting technically is that when you lie, you know that you are not telling the truth. But in bullshitting, you just don't care. and so this is what these models are doing. They don't care. They are just working on this probability scheme. So what can we do about this? Actually, exactly the same that we can do with humans. If somebody says that I know exactly how this goes, what do you say? You ask, how do you know? Where did you read that? Where did you learn that? So this grounding and retrieval augmentation, this is what the current models, many models do. They get back to the references and show you the references. Or uncertainty estimation, Bayesian sampling, meaning they know if they are uncertain. Or ensemble methods, meaning second opinion. You have a number of these models, and if this is something, this is something, if many of them agree, then it is more likely true. Another question, how smart is AI at this point? Since I said that they are a bit like geniuses. Well, we don't actually know. We have seen that they can get in the law school, and they can get out from the business school. Currently, they can also graduate from medical schools and law schools. But is it really smart yet? There's also very recent result earlier this month where these mathematical reasoning models were tested on completely new mathematical problems that definitely are not in the training data. And the result is that these models are lousy. These are really bad. They don't scare pretty much any points there, which means that actually they are not really smart problem solver, but they are memorizing a lot of samples, and if the next question or problem is similar enough, they can do a bit of adjustment and work like this. This is how many students do, of course, for exams. They are reading a lot of previous exams, and this is what these are doing also. So we need to do a lot of work more in this reasoning part. And is it creative? Now there are two types of creativity, artistic creativity and what we need in science and engineering and entrepreneurship and all this. In artistic creativity, we need to ask artists, and World Economic Forum did it, and the result is that this community thinks that, okay, these methods really do this kind of artistic output. I don't know whether it's more about these methods or the artistic community, but anyways, these methods are there now. This is the famous picture of AI image that won a digital image share. But is it creative in science? Now, if you think of the hypothetical deductive model of science, this creativity is a process. You make a hypothesis, which is plausible plausible hypothesis. You don't know whether it's true or not. Then you think, what if this is true? What can you observe? Then you do the observation experimental part, and then you repeat. And actually, this hypothesis generation is exactly the same thing as this hallucination, making probable solution that you don't know whether it's true or not. And actually, the other chemist, Nobel laureate David Baker, has used this extensively for creating new proteins. His group has created 10 million new proteins with these technologies. Okay, and okay, my time's up, so I use only 10 more seconds. In Finland, in Aalto, in Finnish Center for AI, we are doing AI research exactly on this domain. So for real use for also industrial needs, in the case where there's domain-specific issues, insufficient data, proprietary data owned by several parties, compliance requirements that requires that you need to know how certain these are. So these plugin models don't fit there. We have to build specific models. They are based on these general frameworks. Okay, thank you.